Do this one last example in which I'm going to run through how I can use the binomial theorem to expand a binomial. But in this video, we're actually going to focus on what would I do if I had a difference inside my binomial instead of a sum. Okay, because up until this point, we've been discussing how would I expand some binomial that is a sum of two terms to the nth power. And so the trick with differences is that we're going to have to say if I had something minus something to the nth power, we would have to rewrite it as a plus a negative b to the nth power, well, where we will just treat our second term as being negative that term, and we're still going to treat this like a sum. Okay, so we're still going to use the same patterns, Pascal's triangle, power trade-offs, all that stuff. It's just that we're going to treat this difference like a sum of a negative. Okay, so you'll notice I say let's expand the following binomial by first rewriting the difference as a sum. So this x minus y to the fifth, what we're going to do is we're going to reinterpret this as x plus a negative y to the fifth power. Okay, so things I want to identify. Well, the first thing I want to identify is what power we're taking this to. We say the power of n, where n in this case is equal to 5. Also this, we say our first term is, like our a-like thing here is going to be an x, and our b-like thing is going to be a negative y. And by a and b, I mean just like our first term and our second term here. So now that I have these identified, let's go ahead and expand our binomial. So we say the expansion of this would be the first thing to the fifth power, second thing, none of them. We say plus. Now in this instance, we're going to get fourth, first, plus. Now third, second, plus second, third power, plus first power, fourth power, plus, write that 4 a little bit more cleanly here, fourth power, plus, now none of these and all of these. Okay, 5. So now that we've got this scribbled out, what we're going to do is we're going to fill in our terms here where we know that our first term is an x and our second term is a negative y. So I'm going to write x in all of these first blanks here, x, 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 x. And then in the second blank, we're going to write negative y, negative y, negative y, negative y. Thanks for being patient with me here. So think ahead while I'm filling in these negative y's, but the last thing we need to do here is fill in our coefficients. We say, okay, well, what would the coefficients of each of these terms be? And as a matter of fact, these coefficients we get from what we call Pascal's triangle. So recall, Pascal's triangle looks like this. We have a 1, 1, 1. Always 1's on the outside, so 1 here and 1 here. But in the middle here, we would have a 2 because we would sum the 1 and the 1 to get 2. And this would be 1, 3, 3, 1, 1, 4, 6, 4, 1. We would have a 1 here. 1 and 4 give us a 5. A 4 and a 6 give us a 10. 10 and 6, or sorry, 6 and a 4 give us a 10. A 4 and a 1 give us a 5 here, and then a 1 here. The fact is, we were taking this to the fifth power. So what we need is the fifth row of Pascal's, and keeping in mind that the first row of Pascal's corresponds to the 0th power. We would say n equals 1 here, n equals 2 here. I'm going to make it a little bit easier to see. N equals 3, n equals 4. You'll notice that I only filled out to the fifth row because I kind of knew that this is the one we needed. But these will be the coefficients for our terms here in this expansion. So 1, 5, 10, 10, 5, 1. We're going to go fill these in. We say 1, 5, 10, 10, 5, and 1. So things we know to be true. Well, first of all, anything to the 0 power is just 1. So I'm going to cross off these on the outside here. And you'll notice that when we simplify this, which is really what we intend to do here, we say simplify this expression. It's already the expansion. It's correct. We just want to make it look a little bit more cleanly written. So I'd say x to the fifth. Well, I get x to the fifth plus now the interesting thing here is I have 5 times x to the fourth, but I have a negative y to the first power. What do we know about negative things to odd powers? Well, they come out to be negative. So positive times a negative, this whole term is going to come out to be negative. So I could write plus a minus here, plus a negative, but really what I should write is subtract 5x to the fourth y to the first. And the y was the one that caused this to happen. So now looking at our next term in this expansion, which is this one right here, we say 10 times positive x to the third, so that's positive. We get negative y squared, but you'll notice that we're taking a negative thing to an even power. So this negative y squared just becomes y squared, and what we end up with for a term value here is this. We get 10x to the third y squared, where the whole thing is positive. Okay. Now looking at this next term, foreshadowing here a little bit, you'll notice that we get 10x squared, but we get a negative y cubed, and a negative y cubed comes out to be a negative y cubed. So positive times a negative, this whole thing is going to be negative, and we get 10x squared y cubed plus. Now I notice there's this pattern here. It goes positive, negative, positive, negative. We're getting alternating terms, so I suspect that this one will be a positive, and I observe that it does actually come out to be positive. We get 5 times x to the first, positive x to the first, and a negative y to the fourth comes out to be a positive y to the fourth. So we really get 5x y to the fourth, and then our final term here I would suspect to be negative. Let's take a look. Y, we get 1 times negative y to the fifth, so we get negative y to the fifth. So this would be our binomial expansion for x minus y to the fifth, or x plus a negative y to the fifth. And you'll notice that when you have differences, your terms in your expansion should alternate their signs from term to term. Cheers.